Hey Tiberius, want to talk about Java deserialization?
Can it have an anime intro?
Of course! Welcome back to the channel, everybody. Today we're going to be talking about Java deserialization attacks. It's a really interesting class of bugs. Deserialization attacks in general are still relatively new to me, but I feel like I have like a basic understanding, and I don't want to give all of you wrong information. So if you would like to learn more about deserialization attacks in general, this video by Pwn Function is a pretty good one, and it covers how deserialization kind of works at a really high level. So I would totally recommend this video if you're totally new to it. But for today we're talking specifically about Java deserialization, and Vicky Lee. I'm going to tell you right now, if you're not following Vicky Lee on Twitter, you are wrong. Like you don't even know like how bad you're screwing up your life if you're not following Vicky Lee on Twitter. She is amazing. So go give her a follow. We're kind of covering some concepts that she had written in her blog post about Java deserialization attacks. And so at like a really high level, if you think about it in the context of like just general programs that you use over the internet, or even in the case of like video games. So oftentimes programs will have to save a state or transfer the state of a program over the network. And the way that is done is those objects describing the state of the program will either be serialized onto disk or serialized over the network. And then when that state needs to be recovered or an action needs to be taken on it, the byte stream describing that object will be deserialized either on the other server or from disk back into memory and recovered back into an object. And where that becomes an issue is when that deserialization is handled improperly. So that can lead to issues like memory leaks, or kind of going off of the example of my cross-site scripting video where we leverage cross-site request forgery to kind of trampoline other attacks through cross-site scripting. We can do something similar with deserialization attacks where we kind of leverage the deserialization bug to trampoline our way to other serializable gadgets within an application, and then we can, if there's another vulnerability there, we can do something with it. Or if it's like totally screwed up, like with what we're going to be looking at today, it could potentially lead to remote code execution. So to get our lab going, we are going to be working with DeserLab, created by NixtaDB. This is an intentionally vulnerable Java deserialization lab, and the exploit chain for this is going to be a little tricky. But, as we get more into it, I'll describe why. But to get this installed, you're just going to download the DeserLab zip. So let's do that right now. So just going to wget this. And also, probably a good time for me to remind you, don't just haphazardly install and run stuff from the internet. Probably not a good idea, but we're working in lab machines that we don't really care what happens with. And if you're running your lab on a default Ubuntu install, you're going to have to install the default JRE in order for this to work. Otherwise, like if you try and just run the commands as described, they're not going to work. This is kind of the format that we will be running our lab with. So we're going to have this running both on the Ubuntu instance and on our Kali instance. And so we'll just copy this. Okay, so that should be up and running. And we will do the same on our lab machine. Okay, so a relatively simple application. We have the main application, and we also have a Groovy All 2.3.9 library included with it. To later build our deserialization payloads, we're going to be using ysoserial from Frohoff, and it may not be apparent on the GitHub repository, but if you just want the jar file for ysoserial, you can find it down further here under installation. Download the latest jar from Jetpack. And again, I would err on the side of caution of just haphazardly downloading stuff from the internet and running it. So we have our lab machine running. So we can definitely reach our lab machine. Let's open this application up with JD GUI and start to get a better understanding of how this all ties together. Okay, so now that we are looking at the DeserLab application, right off the bat, we can see we just have like a class for general usage. So we're just going to skip right over that. And so if we're running as the server, we want to take a look at the server class. If we're looking for bugs in the client, we want to look at the client class. Pretty straightforward, right? So looking at the server class, I wish there was a way to make that less chaotic. Okay, so looking at the server class, there's kind of some basic things that we need to understand about how this application is structured. So we open up a socket to listen on, and while that socket is listening, we are going to be looking for a client connection. And it appears that we have some sort of handshake-esque functionality. So that's something that we'll have to address when we're writing our exploit. And we also have a hash request function. Seems to be pretty interesting. And once we receive a hash request from the client, we will get that hash, or get the hash of the input from the client. And then this application will print the output of the hash request back to the client. And then it'll wait for a new client connection. So pretty straightforward. So on the client class, what we're looking at is the other side of that, where we connect to the server and we complete like this pseudo handshake kind of client server negotiation, and then we will be waiting on the client for input from us, the user, to make a hash request, and the string that we want to request a hash for will be serialized over the network and then deserialized on the server, and that hash sent back to us. So our actual vulnerability is probably going to be in the hash request function, or in the hash request class. And we see this is serializable, and we got data to hash. So the way that we understand this application now, input from the client is serialized over the network and then deserialized via data to hash, and then the hash value is returned to the client. So if we have a way to deserialize kind of malformed data, is where it gets interesting, because with this Groovy library included in the application, oddly specific. So let's look at what is so special about Groovy 2.3.9. Okay, so right away, we see security vulnerabilities and a remote code execution vulnerability exists between Groovy 1.7.0 and 2.4.3. So if we are sending malformed serialized data to the server, we can leverage the Groovy library that's included with the application to achieve remote code execution. So let's start looking at this application with Wireshark and just get an understanding of what kind of, like, what we need to do to build that client server handshake negotiation, and then what we also need to do to build a serializable payload. Okay, so let's start analyzing the traffic with Wireshark. This should give us a better idea of how to form the traffic that we need to send to the server application and trigger the deserialization vulnerability that we discovered through the hash request method. And what we're going to do right off the bat, we're going to get the server started, and that's already going. I then have a Wireshark filter set for TCP port 5000, just like the server is running on. So any traffic that we send from the client to the server will be captured in Wireshark. So what we're going to do is we're going to look at it kind of step by step, and then we'll run it all at once from client to server, and then we should have a really good, really deep understanding of the data that we need to send. Okay, so let's look at the client hello and version exchange right off the bat. And what we're going to do is we are only going to focus on traffic being sent from the client to the server. And this will help us focus on the data that we need to write into our exploit. So if you had read Vicky Lee's blog post on Java deserialization, you'll recognize these bytes as part of our serialized data. So the entire stream of traffic that we're sending from the client to the server is serialized. It's just that once we hit that hash request function within the server application, that's when our deserialization will be triggered. So up until that point, we want to replicate the traffic via our exploit as closely as possible as legitimate client-to-server traffic goes. So this is the beginning of our serialized data. This is representative of the client hello, and this is our client version exchange. Now, one thing to note is that each of these is going to represent a length of how much data the server is expecting from the client. And that will be important when we get to the client name negotiation. So as an example, if we were to type hello, let me close this out and we will look at our stream again. So if we look at our client hello, right now we have an offset of 7. But if we were to run this again and use a longer name like client 1, we should see that this offset now changes to 9. So that's just one little thing, one important but very small little thing that we'll need to pay attention to as we're building our exploit. So now let's continue on with the serialized hash request. And we will just simply send the string ABC123. You know, I'll actually just leave this as ASCII, so we can see that the hash request class from the Deser application was being used to serialize our string. And on the server's end, the stream of data that we sent to the server was deserialized, converted into a hash, and then the hash was sent back to the client. So where we enter the string ABC123 is going to be our target for our ysoserial payload. Now, before we start writing an exploit, let's take a look at ysoserial and get a better understanding of what we need to do with ysoserial to get a payload generated. Okay, so having ran ysoserial without any arguments, we should get a list of payloads from their respective authors and the dependency for that payload being used. And you might already see it, but the payload that we are going to be using is the Groovy 1 payload, as it is referencing a dependency of Groovy 2.3.9. And if you remember from our code review of the DeserLab application, it includes a reference to the Groovy 2.3.9 library, and that can specifically be found in the manifest.mf file. So Groovy 1 is going to be our ysoserial payload generator. Now, to actually generate a payload with ysoserial, it's pretty simple. We're just going to specify Groovy 1, and then the command that we want to generate a serialized payload for. So this is all fine and dandy. There's just a couple of things that we need to understand. So some of the Java utilities that are being used by ysoserial and by the server application is going to restrict some special characters that we would normally use to get a reverse shell. In this particular case, we won't be able to really do much with pipes or ampersands. So we'll need to design an exploit or a way to take advantage of this deserialization vulnerability without using either of those characters. But that's relatively simple to do, and we'll get to that soon. So now that we understand how and why we're generating payloads with ysoserial, let's start writing an exploit. So there's 3 libraries that we want to import for our exploit. We're going to first import the socket library so that our exploit can communicate with the server application. We're also going to import the sys library so that we can pass command line arguments to ysoserial. We're also going to import the popen and pipe methods from subprocess so that we can build a wrapper around ysoserial. Right off the bat, we're going to create a command variable so that we can capture command line arguments. And we will then define a main function taking our command variable as an argument so that we can work with that relatively easily. And then we are going to invoke that right off the bat. So just as a quick recap, so we have good data to go off of, let's run the client application once more up until the portion where we're sending a string to be converted into a hash. We'll enter client1 as our name. And this is the data that we want to design our exploit around. So we want to set our first packet to be that of our serialized stream. And we will finish off the client hello with the bytes that we had discovered previously. And we will put all of these into one variable called client hello. Next, we will want to create a client version variable. And this will be the data that we had observed previously. And we will then want a client name variable with the bytes and offset that we had discovered previously. Now let's start building our wrapper for ysoserial. And I will maximize this so it's easier to read. We'll then use a formatter for our command variable. And that should complete the wrapper for ysoserial. Now here's the tricky part. So when we're using our ysoserial payload as our hash request, when we generate it with subprocess, we're going to get some extra bytes that we don't want. And I will actually show you that right now. So as you can see, we have some extra data here at the beginning of our ysoserial payload, and we don't want these bytes because we're already specifying that in our exploit previously. So we're just going to use some crafty Python magic to skip over these bytes and begin our payload right here. Once that's done, we can start building our socket. And we will use some try and accept logic so that if we ever have a socket error, we will be able to get some more refined information on what exactly caused the error. And while we're doing this, we'll want to print some generic feedback to us so that we know at what point in our exploit we're currently sending data to the server application. And this is just like generally useful exploit development skills. So first we'll want to know that we are going to send a client hello. And next we will want to be able to understand that we're at the point where we're responding to the server's request for a client version. Now we want to respond to the server's request for a client name. And finally, we can start generating our ysoserial payload. Now, if you remember, when we get to the point where we're sending a string to be hashed, we actually need to receive data from the server on this before we can close out the socket. Okay, so now that our exploit is finished, let's run it locally against the server instance running on our Kali machine, and then let's try and see if we can get it to ping before getting crazy with trying to get a shell. Okay, and we see that we have some sort of length violation with our data. But ultimately, we're still able to use this, so it might not be perfect, but it's still usable. It just might not be totally reliable. Okay, so now that that's done, let's try and get a shell. Let's think of some ways that we can potentially go about doing this. Okay, so we're actually going to be running the exploit against our lab machine, and what we want to do is we want to be able to get a shell, but we have some restrictions with the way that we're doing that just by nature of which methods and classes that the vulnerability exists in, as well as the ones being used by the server application itself. So again, we won't be able to really use ampersands or pipes, but we may be able to download something to disk and then execute it afterward. It's not the most stealthy or elegant solution, but in this case, I think it'll work. So first we need to redirect our exploit from localhost to our lab machine. And in my case, that will be 192.168.195.128. Okay, so for this, we want to have both a web server running as well as a netcat listener. So we'll get the netcat listener going first. And then we will run a simple HTTP server with Python. And finally generate a payload that we can use to download to disk and then execute it afterward. We can do that with refshellgen. And we will just save this as shell.txt. Might not even need this terminal. Okay, so with our exploit. Okay, so let's try downloading our shell.txt file to disk, and then we'll try executing it with bash. And there we go. Now, it might be a little curious why this is running as root. I just did that on my lab machine so that you would be able to clearly tell that we have now accessed the lab machine via deserialization exploit versus, perhaps getting a shell from my localhost. So that's why I did that. So thank you once again for joining me, everybody, and a special thank you to Tiberius for doing the intro video with me. It was just like a spur of the moment kind of thing, and I try not to take myself too seriously on this channel, but I also don't want to give all of you bad information either. And it's people like Tiberius, it's people like Vicky Lee, it's people like Pwn Function that are going to be able to give you way more detailed information about web application penetration testing and web application security than I will probably ever be able to. So, branch out as much as you can. Learn from as many different people as you can. I'm just one guy and just trying to round out my skill sets. That being said, my kitchen's in total disarray, so make sure you're cleaning up your kitchen, throwing away, leftovers, spoiled leftovers. Yeah, get plenty of sleep, and that's about all I've got. So, thanks. See y'all in the next one.